In the previous video, we saw why traditional neural networks fail for images. Now let's try to understand the core idea behind CNNs, Convolutional Neural Network. How does CNN scan the image? CNNs analyze images using something called a filter, also called a kernel. A filter is a small matrix of numbers, for example, 3 by 3 grid. Instead of analyzing the whole image at once, the filter looks at a small patch of the image. The filter then slides across the image, analyzing one small region at a time. This sliding operation is called convolution. So let us visualize this. You can see the filter, which is in dark blue color, is sliding across the our image, and then while it is sliding, it is preparing a future map. Each time it slides, it creates one pixel of the future map. But you can also see the size of our original image has been decreased when it comes to the size of future map. I mean, the size of original image is bigger than the size of our future map. So let us see how this is actually calculated in computers. We have this image, we have this filter. So this filter looks at small portion of the image and it multiplies element wise, and then we add each of the multiplied result. For example, 0 into 1, 0 into 0, 0 into 1. We'll multiply each element of the pixel and each element of the filter, and we'll add the resultant multiplied values like this. We'll have one single value. So that single resultant value is responsible for one pixel value of our resultant future map. The output after applying the filter to original image is called as future map. So each filter is responsible for identifying something, maybe vertical edges, horizontal edges, or something else depending on our use case. So that filter tries to find if it can identify any pattern or any feature in that image, and it captures all the details regarding that particular pattern it cares about and prepares a future map. So as this filter slides from left to right and top to bottom, we will have our future map filled completely. We will see what are the kind of filters we will have. One of the most important visual features in images is edges. Edges occur when there is a sudden change in brightness between neighboring pixels. For example, the boundary between a shoe and the background creates an edge. CNN filters can detect these edges automatically. Here we see two types of edges. A positive edge, when brightness changes from dark to light. A negative edge, when brightness changes from light to dark. When filter detects an edge, it produces a large value. The sign simply tells us the direction of the change. This filter detects vertical edges. It compares the left side of the image with the right side of the image. If there is a strong difference between left and right pixels, the filter produces a large value. If we rotate this filter by 90 degrees, we will have a horizontal edge filter. Now this detects changes from top to bottom instead of left to right. CNNs detect patterns using many filters like this. Some filters detect edges, some detect textures, and some detect more complex shapes. So filters allow CNNs to transform an image into future maps that highlight important visual patterns like edges. When we apply a filter to an image, the result is a future map like this. Bright areas in the feature map indicates where the filter strongly detected the pattern. If the filter detects edges, the feature map highlights all the edges in the images. Each filter produces its own feature map. CNNs usually they do not use only single filter; they use many filters at the same time, each detecting different patterns like edges, curves, textures, shapes, etc. But who designs these filters? Um, how do you know this filter detects vertical edges? How do you know this filter detects horizontal edges? How do we know that our image requires these many filters or these kind of patterns to be identified, so that our model will be able to identify or recognize the pattern? In traditional computer vision, engineers manually designed filters like this, but deep learning changed this. In modern CNNs, the filters are learned automatically during training. Like a neural network, we will have weights that are trainable, right? Similarly, we will leave the filter as weights. When we are training, we will initialize a random numbers and we will tune the weights based on the feedback we get from back propagation. So convolution allows CNNs to scan images and detect important patterns like edges and textures. But there is still an important question, right? What happens when we apply many filters and many convolution layers? How does the network combine all these features to understand an image? In the next video, we will explore how CNNs learn complex features and build hierarchical representations of the images.